is, chalo, please pay attention, and I'm just revising what we have done in previous session, and then we will move ahead with what we will be doing in this session. ठीक है? Please pay attention, all of you. Angular variables. We are aware of angular variables: angular displacement theta vector, angular velocity omega vector, angular acceleration alpha vector. Anyone who is having any challenge in understanding these angular variables? So let's start with Stuti Jain. Stuti, do you have any queries or concerns about this?
No, sir.
Okay, so if I ask you that an object is, if I tell you that an object is moving in anti-clockwise sense, right? What is the direction of its angular displacement? Can you please let us know? If this is the circle is in the XY plane, then what is the direction of this angular displacement theta vector? Yes, Stuti.
So, anti-clockwise.
No, anti-clockwise and clockwise are sense of rotation. They are not directions of rotation. So what is the direction of the rotation of this?
Can I tell?
You are Preetham.
Preetham.
Yes, Preetham.
So K cap.
K cap. So how did you get that, Preetham?
So we did it in last class.
So what did we do that then? What did we do? You curl your right hand palm fingers in the sense of rotation of the object, right?
Yes, sir.
Tuti.
Oh, yes, sir.
Okay. So you curl your right hand palm fingers in the sense of rotation of the object. The thumb will point, stick your thumb out. The thumb will point in the direction of theta. So in this case, it is theta plus theta vector is theta plus k cap. I hope all of you agree to this. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then came angular velocity omega, then came angular acceleration alpha. All of you are aware of it. So when the alpha is constant, then we have equations of circular motion, right? Omega f is equal to omega I plus alpha vector t. Theta is omega I t plus half alpha t square. Omega f is equal to omega dot I dot omega I plus 2 alpha dot theta. Last class, we have already done this in circular motion also, right? Any doubts in this? Recall value है या नहीं है अभी इसकी? हेलो सार्थक, तुभ्या, वशिष्ठ, तरुशिखा, निशांत, नारायणन है ना? नवीना, मनन, लास्ट क्लास में तुमने देखा मनन गोल्ड से जाके सर्कुलर मोशन का चैप्टर बेटा?
नो सर,
नहीं देखा? तो
बाकी रह गया।
तुमने पहले सर्कुलर मोशन किया है क्या कभी?
11th में किया था।
हाँ, तो कुछ याद आएगा। देखो, एक्चुअली देख लेते तो अच्छा रहता, क्योंकि एक ही लेक्चर हुआ था इसका, है ना? तो वही मैं रिवाइज करवा रहा हूँ अभी, उसके बाद तुम जाके देख सकते हो, ठीक है? उसको
ओके सर।
उसका जब टर्न आएगा मैं दोबारा करवाऊंगा उसको, बट कनेक्टिविटी बनी रहेगी। जैसे अब कल तुम नए लेक्चर में थे इसलिए चल रहा था, है ना? वो तो उसमें प्रॉब्लम नहीं था मुझे। इसमें थोड़ा सा तुम याद करने की कोशिश करनी पड़ेगी बेटा, ठीक है?
यस सर।
Okay. So these were equations of motion, circular motion. Then came, we used there, these are some essential notations and equations in circular motion. ET cap was tangential. ET cap is tangential unit vector. ER cap is radial unit vector. Position vector is R vector, which is equal to R cos theta I cap plus sin theta j cap. We did this, right, in the previous session. And velocity vector is always along tangential direction. We are all aware of it. Yes or no?
Yes, sir.
है ना?
Yes.
इसके लिए तो we need not have to be now revisit the entire chapter now. Okay. Now today we will be discussing about circular turnings and banking of roads, right? But before that, I would just like to remind you what we did in non-uniform circular motion in the last class. We discussed about centripetal acceleration. We discussed about net acceleration. You remember net acceleration? It has two components. One is tangential acceleration. The other one is radial acceleration. in terms of velocity, tangential acceleration is given as dv vector, sorry, this is given as dv by dt et cap, right? You guys are having some, my background noise is coming to you, or it's okay with you?
So no background noise is
No
coming. It's
background
okay.
noise, ना? हाँ हाँ, वो बाहर नीचे बच्चे खेल रहे हैं, बहुत शोर कर रहे हैं, and I am using a different mic. So this is dv by dt et cap plus v square over r. This is minus er cap. I hope all of you remember it. Yes or no?
Yes, sir.
And this is a vector is dv vector upon dt, and this is dv by dt et cap plus v square over r minus er cap. This was in terms of v, right? In terms of omega, we can write it as r d omega by dt et cap. Et cap is tangential unit vector, and this is omega square r minus er cap. This is a vector. I hope all of you understood this and you remember it.
Yes, sir.
This term, Manan, please pay attention. है ये तुम्हारे लिए बता रहा हूँ. The rest of them are aware of it. This
Yes.
term is called as, anybody who would like to recall, what is the difference between these two terms, this one and this one?
तो एक स्पीड होता है और दूसरा
और दूसरा
दूसरा वेलोसिटी.
एक है rate of change of velocity, which is the net acceleration. The other one is rate of change of speed, which is the component of the net acceleration, or it is the magnitude of tangential acceleration, right? This is representing the tangential acceleration, and this is representing the linear velocity, the rate of change of velocity, the net acceleration. I hope all of you remember this thing. Yes or no?
Yes, sir.
Okay. Okay. And then we had, if for uniform circular motion, we discussed this, right? Since it's time, so I am just trying to revise it for you. So uniform circular motion mein, what did we do? We discussed about what happens when omega is a constant. What happens when omega is a constant, right? So when omega is constant, what will happen? D omega by dt becomes 0. Yes or no? All of you.
Yes, sir.
So here, check where is this d omega by dt. So the net acceleration, from here, the net acceleration will become omega square r minus er cap. So we can see here, or you can also write in terms of v, you can write it as v square by r minus er cap. So this a vector is directed towards the center of the circular path. Can you see this? This net acceleration is directed towards center of the circular path. Yes or no?
Yes. Yes, sir.
Yes.
So this has a special name, and it is called as centripetal acceleration. And it comes because of the net force acting towards the center of the circular path, or else the acceleration will be radial acceleration. If it's a non-uniform circular motion, then this acceleration is called as radial acceleration. If it is uniform circular motion, then we call it as centripetal acceleration.
Centripetal acceleration.
याद आ गया सबको? All of you now recalled it? Yes or no? Rajshri, Aditya, Arush, Ashish, Pritam, Pavni, Ojas,
Yes, sir.
Nirakshana, Navina,
Yes, sir.
Datta,
Yes, sir.
Yes, sir.
Ramya Shri, Stuti, Tarushikha, Tubhya, Siddhant Pal,
Yes, sir.
Sarthak.
Yes, sir.
Siddhant, you are not there in the last session, beta.
नो सर.
क्यों?
सर गेस्ट आए हुए थे, फिर बाहर चले गए सर.
अच्छा, चलो, तो ये हमने किया था. Manan, you need not have to write it. It's already there in the recording, so you can watch it from there. ठीक है?
Okay,
जस्ट
sir.
अभी के लिए फिलहाल के लिए ना बेटा, अभी जस्ट थोड़ा सा होमवर्क, अभी क्वेश्चन करवाऊंगा तो उसके लिए तुमको याद करवाने के लिए मैंने ये लिखा है ये, ठीक है? यू कैन टेक अ स्क्रीनशॉट इफ यू वांट टू रेफर टू इट।
Yes.
चलें आगे। So let's discuss a very important application of this, circular turnings. ठीक है? Please pay attention. We are discussing circular turnings. देखो, it is very, very simple. Huh? We have these turns here. ऐसा कुछ है ये, ठीक है? And an object is taking a turn here. So an object is taking a turn here. ठीक है? And it is taking a turn with a velocity v at this point in time, right? The friction coefficient between the tires and the ground is mu. Okay. So if I draw the free body diagram, what we have here is mg downwards, normal reaction by the ground on the tires is n upwards, right? And it is neither skidding nor sliding. कहीं नहीं जा रहा है, ना अंदर की ओर जा रहा है, ना बाहर की ओर जा रहा है, right? What will happen here? Since this v is constant, so it's undergoing uniform velocity, right? Since this v is constant, it is undergoing uniform velocity. So now we have this acceleration here towards the center. You are all aware of it, right? What is that acceleration? Centripetal acceleration. And what is that? V square over r, where r is the radius of the circular path. Anybody is having any doubts till this point? Yes or no? No? Okay. Okay. Now tell me, friction, see, this acceleration will not be because of any random force, right? It is because of some force which is acting in its direction. So what is the other force which is acting here? The only force which is left out here is friction. See? So friction is the force which is acting towards the center of the circular path. I hope all of you understand this. Yes or no?
Yes, sir.
And let's call this friction as, say it's Fs because it's neither skidding nor slipping. तो अंदर की ओर slip तो नहीं हो रहा है वो, ठीक है? So this Fs is playing the role of centripetal force, right? And what is the value of this Fs? It's mass of the object into v square over r, the centripetal acceleration. Anybody is having any doubt till this point? Manan, you understood or not?
Yes, sir.
कहीं नहीं समझ में आएगा ना बेटा तो पूछना, एक्चुअली क्या होता है नहीं समझ में आएगा कभी तो उसमें डर वो मत सोचना, ठीक है, कि क्यों नहीं पूछना. हाँ, so this Fs is less than or equal to Fs max. We are all aware of it. And what is this Fs max? It's mu s times normal reaction n. What is normal reaction n here? It's mu s mg, right? All of you please pay attention. So we have here v square by r is less than or equal to mu s g. तो यहां से तुम्हें क्या मिला? v is less than or equal to root of mu s g r. बोलो बच्चों. I hope all of you understood this. Yes or no?
Yes, sir.
So now always remember it's a constant. The velocity should always be less than or equal to root of mu s g r, right? For a safe turning of this vehicle. Got it? So v depends on which values? gr to constant hai. For every vehicle it will be constant, but it depends on the coefficient of static friction.
Yes, sir.
It depends on the coefficient of static friction. समझ आ रहा है नहीं आ रहा है?
Yes,
All
sir.
right.
Please copy it quickly.
Yes, sir.
See why I am doing all these derivations for you just to make you understand, right? ये नहीं भी करूंगा तो भी चलेगा, तुमको मैं माइंड में आप सिखा सकता हूं, बट ये कर लोगे तो तुम्हें याद रहेगा. You will have a better understanding of applications. Once you are done writing, please type done in the comment window. Huh? Sir, why we took Fs is equal to Fc? See, Ojas, में तुम last class में थे या नहीं थे?
Yes, I was there.
What is definition of centripetal force?
So the component of force along
नहीं, नहीं. फिर से पढ़ो. कॉपी में लिखा है तुमने या नहीं लिखा? नोट्स पूरे ढंग से बनाते हो कि नहीं बनाते हो? तुम ईमानदारी से बोलो.
Yes, sir.
अगर तुमने नोट्स मेरे लिखे हैं लास्ट क्लास के तो उसको निकालो और उसमें सेंट्रीपिटल फोर्स की मैंने डेफिनेशन लिखवाई है. प्लीज देखो उसको. क्या मिला? सार्थक, व्हाट इज सेंट्रीपिटल फोर्स?
सर निकाल रहा हूँ डेफिनेशन.
ये याद नहीं तुमको? ओजस्वी जी, मिला कि नहीं मिला? पावनी, एनी आइडिया अबाउट सेंट्रीपिटल फोर्स?
Yes,
बेटा
sir.
हाँ बोलो बोलो.
So the net force directed towards the center of circular path.
Net force directed
Towards the
towards the
center.
center of the circular path. बताया ना? तो यहाँ पे कौन सा नेट फोर्स है बेटा?
Sir,
कौन सा फोर्स है जो सेंटर की तरफ है?
Fs.
अब वो Fs जो था वो आया क्यों था? बिकॉज एक्सिलरेशन से फोर्स हमने इंटरप्रेट किया है ना, क्योंकि उसका डायरेक्शन होना चाहिए रिलेटिव मोशन का. तो हमको और कोई फोर्स मिला नहीं यहाँ पर. देयर इज नो अदर फोर्स अदर देन दीज थ्री फोर्सेज. यस और नो?
Yes, sir.
So Fs is the force and that is the only force which is directed towards the center. So that is centripetal force.
Okay, sir.
चलो, मनन को समझ आया कि नहीं? पावनी समझ आया
Yes,
बेटी?
sir.
Yes, sir.
ओके. स्तुति
Yes, sir.
ठीक है. So now this were, so if you are if you now see this data here, what is happening is V is dependent on what? Mu. This mu will change for every vehicle. This mu will change for, will be different for different duration, for different tires who have actually been installed for different durations, right? It depends on the wear and tear of the tire. So we need to reduce the dependency of this mu, of this V on this mu. We want to make this V independent of mu s, right? Actually, we want to have a range of velocity. Okay? So let's see what is that range here. I'm not, चलो derivation कर ही लेते हैं इसकी. नहीं, मैं इसका डेरिवेशन नहीं करवा रहा हूँ तुमको, इसका मैं सीधे डेटा लिख रहा हूँ. तुम्हें सुनो ध्यान से. नहीं, पहले बैंकिंग कर लेते हैं. So this is banking of road. So we want, if we want to reduce the dependency of the vehicle on the friction coefficient, then we do the banking of roads. Right? What we do is we elevate the road on the outer side of the track. We elevate the roads on the outer side of the track. If you have seen tracks of bicycle race in Olympics, right? The tracks are elevated outwards. If you have been to mountains, then in the turnings, the tracks are elevated. The road is elevated in the outward direction. Have you seen that? Anyone who is aware
Yes,
of it?
sir. Yes, sir.
So this angle is theta, right? This angle is theta. This is the track here. Sorry, this is the vehicle here. Give me a second. There is some problem with my laptop. I need to check it. Give me a second. Yes. So here what happens is, this is the this object is taking a turn on this bank road. Okay. This object is taking a turn on this banked road. These are its tires. Okay. And you are seeing the rear view of it. So this is the radius of the circular track. This is the radius of the circular track. mg is acting downwards. Normal reaction here. N mg, right? So we resolve the forces along the center and perpendicular to it. So here this n is perpendicular. This is the vertical component of n. This angle is theta. So this is n cos theta, right? And this is n sin theta. I hope all of you understood this. Yes or no?
Yes, sir.
So this is n sin theta, n cos theta. Here n cos theta minus mg is equal to 0. And we also have this n sin theta as the centripetal force, right? This is n sin theta. So you solve it for V now. I'll be Done, all of you? Hello.
Yes, sir.
So when you solve it, what you get here is n sine theta is equal to mv square over r. And we have n cos theta as mg, right? Take the ratio of it, you get tan theta as what? It's v square over rg. So v is root of rg tan theta. Now you can see here that we have reduced its dependency on mu. Got it, all of you? But there is only one value now. See, there is only one value, right? So all the vehicles have to take turn with this velocity. Will it be easier for them to do that? Yes or no?
Yes, sir.
Oh, how it will be easier for them for a specific velocity only if you
Sir,
write 30
एक
kilometers
रेंज
per
होनी
hour?
चाहिए ना, लाइक एक
हाँ?
स्पेसिफिक वैल्यू से कैसे टर्न लेगा कोई भी?
नहीं ले सकता है, उसको उस प्रिसाइज वैल्यू पे जाना पड़ेगा, हमेशा जा
हाँ
सकता है
मतलब
क्या?
नहीं नहीं
इजियर
वो
है या नहीं है? मेरा क्वेश्चन ये है, इज इट इजियर और
नहीं
नॉट?
थोड़ा सा डिफिकल्ट रहेगा.
ये काफी डिफिकल्ट है, ठीक है. So that's why what we want is we want a range of this velocity, right? We want a range of this velocity, and for that range, what we do is we use the coefficient of friction. For this range, we use the coefficient of friction to find out the range. Now, I'm not deriving it for you. You can actually go and watch the recordings. It's given there. I have already done it multiple times, right? So there is a minimum velocity. This velocity v lies in between two values. Ek v max hai, and the other one is v minimum, right? I'll tell you those velocities. You just, first of all, you copy this one, and then we will move ahead to discuss that. Done? Once you're done writing it, please let me know. And if you have any queries, please ask. Chalo. Done, all of you?
Yes, sir.
Excuse me, sir.
हाँ बेटा बोलो.
Sir, for here the centripetal force, we would be taking friction also, right?
No, there
And
is no friction here. We are not considering friction at this point in time. Friction
Okay.
friction will be along this direction. वो तब आएगा जब हम उसको consider करेंगे. अभी we are not considering friction. We are just
Okay.
using the banking of road to understand what will happen if there is only banking of roads. There is
Okay,
no
sir.
friction between the track and the tires of this.
Okay,
तब
thank you.
तब क्या है ये देख रहे हैं हम, ठीक है. We will use the friction to find the range of the velocity. ठीक है, that will help us to find range. All of you understood this?
Yes, sir.
लिखना हो गया सबका? लिख लिया बेटा सबने?
Yes, sir.
Yes, sir.
राम्या श्री, निरक्षणा, नवीना, मनन, दत्ता,
Yes, sir.
Yes,
स्तुति, स्तुति, तरुशिखा, सर्वेश, सिद्धांत. Sarvesh, you
Yes.
understood?
Yes, sir.
Okay. Now all of you please pay attention. See this. We are considering the friction here, right? This angle is theta. The object is taking a turn here. देखो बच्चों. Here what will happen is when you consider friction here, please pay attention. Huh? When you consider friction here, what happens is there is a range of this velocity, right? The minimum velocity for no sliding. Sliding का मतलब क्या हुआ? The vehicle will not slide down the track. Okay. For that, the velocity is minimum velocity, and that is equal to root of tan theta minus mu upon 1 plus mu tan theta into Rg. This derivation is already there in the recorded session. Please go and watch it. Okay. And for no skidding, what is this V max? See, what will happen is, this is the minimum velocity, right? To prevent slipping or sliding. Now you keep on increasing the velocity. At some point in time, what will happen is this object may go outwards. Okay? That is skidding case. So the maximum velocity for no skidding is root of gr tan theta plus mu over 1 minus mu tan theta. Okay. This is V max. So we have an entire, what was V there? Without mu, what was V? It was root of Rg tan theta. You can very well see here that if just remember these data, this will help you. Those of you who are in 11th standard and 12th standard, see if it is there in your syllabus in your schools, please go and watch the derivation part of it. And if you don't understand it, ask me. Now, the velocity without mu, which was there with us, was root of gr tan theta, right? Now, this velocity lies in between. All of you can see it lies in between V max and V minimum. Check. Yes or no? Check karo, हाँ या ना? This is root Rg tan theta minus mu hai yahan par in the numerator, right? You can see here tan theta minus mu into root of Rg. So this is less than V and this is greater than V. Got it or not? All of you?
Yes, sir.
Please remember
Yes,
these
sir.
data. These are very important. Okay? Copy it quickly. Then I'll teach you centrifugal force. Tomorrow we will do numericals based on this chapter. Okay? So I'll give you some homework to do. If you have, just attempt those problems. If you have any doubts, we'll see your doubts also. And we will do numericals also. ठीक है? आज भी करेंगे.
Sir, I didn't exactly understand, like, how did we get to minimum and maximum?
मैंने बोला तुमको इसका रिकॉर्डिंग है, डेरिवेशन है इसका पूरा. ठीक है? मैं इसीलिए कहता हूँ क्लास में, मैं 2 बार 4 बार बोलता हूँ क्लास में प्लीज
Sir,
रिकॉर्डिंग
I
देख के
heard
बैठो.
that.
Then, तो अब मैं क्या कर
Okay,
सकता हूँ?
sir, but actually, sir, what is exactly skidding like?
स्किडिंग मतलब गाड़ी जो, अगर तुम टर्न ले रही है, तुम्हारी कार है, भगवान न करे कभी ऐसा हो, वो कार बाहर की ओर जाने लगे, अगर ट्रैक में बाहर की तरफ मतलब अगर तुम पहाड़ों पे चल रही हो, अगर पहाड़ों पे तुम्हारी कार टर्न ले रही है, ठीक है, फॉर एग्जाम्पल, चलो किसी एक्स आदमी की कार टर्न ले रही है, कार पहाड़ पे, तो अगर वो बहुत तेज स्पीड से करेगा तो क्या होगा, हो सकता है बाहर की ओर उड़ के वो खाई में गिर जाए, हाँ या ना?
Yes, sir.
और बहुत धीरे चलेगा तो हो सकता है स्लिप करके नीचे टकरा जाए इधर आके.
Yes, sir.
तो वही स्लिपिंग और स्लाइडिंग का मतलब है, और वही स्किडिंग मतलब बाहर फेंकना. ठीक है?
Okay, thank you,
हाँ.
sir.
यू आर स्तुति.
Yes, sir.
Excuse me, sir.
हाँ बोलो.
Sir, at V, what would happen? Like it would do a smooth curve?
We were not considering mu there, right?
Yes, sir. Like at that point, it would take a smooth turning.
नहीं, स्मूथ टर्न तो v मिनिमम से लेके v मैक्सिमम के बीच में कुछ भी होगा, स्मूथ टर्न है. इट्स अ सेफ टर्न.
Okay, so
So
at
that
this
was one
particular.
value which was independent of mu. The rest all the values will be dependent on mu.
Okay, sir.
ठीक है? अभी रुको, तुमको सेंट्रीफ्यूगल पढ़ाता हूँ, फिर उसके बाद ये बताऊंगा इसको कैसे लिखते हैं. ठीक है? v मिनिमम v मैक्सिमम. लिख लिया ये? ऑल ऑफ यू रिटन दिस, नोटेड इट?
Yes.
चलो.
सर एक बार प्लीज दिखा दो, 1 सेकेंड के लिए बस. डन सर, वो वी मेन वाला पार्ट रह गया था.
चलो, अब है तुम्हारे पास क्या? rotating frame of reference. Now, I am assuming that all of you are aware about pseudo forces. Yes or no?
यस सर.
Yes, sir.
Manan, are you aware of pseudo forces?
Yes, sir.
These forces comes into being when they are applied when we observe the object from rotating, from non-inertial frames, right? Or from
Yes, sir.
accelerated frames. Yes. So now we have this track here. This is a cylindrical elevator. This is a box which is kept here. The mass of the box is small m. And this is an observer here, which is, say, some observer A. There is another observer B, and he is on the ground. All of you please pay attention, हाँ? ये समझो, फिर उसके बाद वो तुमको वी मैक्स वी मिनिमम भी लिखना सिखाऊंगा. उसको पहले इसको समझो, इसके समझे बिना वो नहीं होगा. Now this elevator is making turns with a constant angular velocity omega. It's rotating with constant omega. The radius of the elevator of the cylinder is r. ठीक है? The radius of the cylinder is r. And mu is the coefficient of friction between the block and the ground. Mu is the coefficient of friction between the block and the floor of the elevator. Now, the block is not sliding over the floor. Neither this man A is sliding over the floor. They are diametrically opposite. This man B is on the ground. So this man is in inertial frame. Yes or no, all of you? He is in a non-accelerated frame. All of you.
Yes, sir.
Yes, sir.
Now, ये inertial frame हो गया. अब non-inertial क्या होगा बताओ? तो अच्छा चलो पहले non-inertial से बनाते हैं, ठीक है? With respect to B, let's draw the free body diagram of the block. How will it look like? So this is block. It is kept on the floor of the elevator. It's mg downwards, normal reaction n upwards. And since it is undergoing in a circular path, ये circle में घूम रहा है ना, तो it has a centripetal acceleration towards the center. Omega is constant, right? So centripetal acceleration is what? Omega square r. And what is the direction of friction here? Towards the center. Okay. So this friction is static friction. So Fs is equal to, it is also the centripetal force. Fs is equal to m omega square r, which is less than or equal to what? Fs max. So here we have m omega square r is less than or equal to mu n, which is mu n is what? Mg. So from here we get omega square is less than or equal to mu g over r, or omega is less than or equal to root of mu g by r. Anybody is having any doubt here? So the maximum angular velocity with which this elevator can rotate is, for which the block will not slide, is what? Root of mu g over r. Any doubts in this B part? Sorry, with respect to B. Hello.
No, sir.
No, sir.
Please check. If you have any doubts, please ask. Chalo, nahi. So with respect to A now, please pay attention, all of you. With respect to A, what will happen? The block is at rest, yes or no? All of you, tell me whether the block is at rest with respect to A or not.
Yes, sir.
Yes,
They are diametrically opposite. They are stationed diametrically opposite, or they are placed diametrically opposite. So mg is downwards. Normal reaction is n upwards. Obviously, friction is a real force, so it will be acting towards the center only, right? This is friction. And now tell me, this person is standing in an inertial frame or a non-inertial frame? Pavni?
Non-inertial.
Okay. Who said non-inertial, Avi?
Sir. Myself, sir. Ramesh, sir.
Ramyashri. Okay. Very good. Why you can say this? It's a non-inertial frame.
Sir, it is accelerating, sir.
How you are aware of it? Huh?
Sir, it is in motion, sir. Like
Rotating, sir, we are
rotating.
rotating the.
It is rotating. So the point, always pay attention to the point, right? Please pay attention. This point on which the observer is standing is having an acceleration towards the center. Yes or no?
Yes, sir.
All of you, please say.
Yes, sir.
You understood
Yes,
or not? When the point on which this observer is standing is accelerated towards the center and its acceleration is omega square r. Yes or no? So it's a case of accelerated frame of reference. All of you understood this or not? All 11th standard students, you understood or not?
Yes, sir.
Stuti, Siddhant, Sarvesh, Sanvi.
Yes, sir.
Okay. So now, since it's a case of non-inertial frame, so there will be a pseudo force. What is the direction of pseudo force? Its direction is mass into omega square r, radially outwards. Clear hai? Mass into acceleration away from the opposite to the direction of acceleration. The acceleration of this point was, please pay attention all of you. The acceleration of the point on which this man was standing is towards the center, right? So pseudo force on this object with respect to this man will be away from the center. Yes or no? Understood or not?
Yes.
That's why this is the pseudo force.
Yes.
This is the pseudo force. स्तुति जी, आपको समझ आ रहा है कि नहीं आ रहा है कि आपका नेटवर्क खराब है?
Yes, sir, I understood. There was just some glitch, so.
So this is the pseudo force, right? And this force is called as centrifugal force. This force is called as centrifugal force. Clear? Hello.
Yes, sir.
Yes,
Now
sir.
you write the force equations. This object is at rest, right? So F minus m omega square r is equal to 0. N minus mg is equal to 0. So now we have Fs is equal to m omega square r. Again, it will be less than or equal to Fs max. So this is m omega square r is less than or equal to mu mg. Right? Or omega is less than or equal to root of mu g over r.
Sir, so we can solve with any frame of reference, like it didn't matter the answer. So it's not necessary to take a
Sorry,
non-inertial
फिर से
frame
बोल
or.
बेटा, फिर से बोलो please. Sorry.
सर मतलब आंसर ओवरऑल दोनों का सेम आया, सो फ्रेम ऑफ रेफरेंस इनर्शियल या नॉन इनर्शियल दोनों ले सकते हैं, मतलब कोई भी एक ले
देखो,
सकते हैं.
बिल्कुल ले सकते हैं, बट मेरा प्रेफरेंस हमेशा नॉन इनर्शियल फ्रेम रहता है क्योंकि वो एक डायरेक्शन ऑफ मोशन रिड्यूस कर देता है. इस केस में तो दोनों में कोई बहुत फर्क नहीं दिख रहा है, बट जब मल्टीपल डायरेक्शंस ऑफ मोशन होते हैं ना, तो व्हेन यू चूज नॉन इनर्शियल फ्रेम ऑफ रेफरेंस, one direction of motion gets reduced, and that is quite helpful. ठीक है, it saves a lot of time.
ओके सर.
It's your choice. Choice इसमें तुम्हारी है, but again चैलेंज वही है कि मतलब मैंने जो तुम्हें रीजन दिया वो है उसमें. ठीक है.
ओके सर, अंडरस्टूड.
हाँ, प्लीज कॉपी इट ऑल ऑफ यू. I hope all of you understood this centrifugal force. Don't compare it with centripetal force, right? Centripetal force is a real force. This is a pseudo force. There is no centrifugal acceleration. There is always a centripetal acceleration. Hmm. Once you're done, please type done in the comment.
Excuse me, sir.
बोलो.
Sir, we are assuming it to be static friction, right? It would depend on the question, no?
Static ही होगा अगर हम ये मान रहे हैं कि the object is not sliding over the floor or slipping over the floor. That means there is static friction only.
Yes, sir.
All of you done with this?
Yes, sir.
सबका हो गया है भाई? हाँ ना बोलिए सब लोग.
Yes, sir.
Yes, sir.
No, sir.
ठीक है. हाँ हाँ नो वाला जल्दी करो.
Done, sir.
Let's use this thing to understand the values of maxima and minima. Those of you who are interested, right? And please watch the recording of this session of the from the Physics Pro Gold or live 11th standard. As soon as you finish with this, okay? Please pay attention, all of you. See what happens here is we are observing this object, this truck or whatever you call it, from inside the truck, inside the vehicle, right? So what will happen here? There will be this mg downwards. There will be this normal reaction in this direction. And since it is taking a turn, right? So it has us, there is a centrifugal force here. And what is that centrifugal force? It's mv square by r. Yes or no? All of you. Hello. Hello.
Yes, sir.
Understood or not this centrifugal force, all of you?
Yes, sir.
अरे बाकी लोग सो रहे हो जाग रहे हो? राम्या, श्री, स्तुति, सिद्धांत, सर्वेश, सार्थक, तरुशिखा, तुभ्या.
Yes, sir.
Yes, sir.
तुम लोगों को यस बोलने में कितना टाइम लगता है बच्चों? कोई नहीं, चलो इधर देखो ध्यान से. Now what we will do here is we will resolve these forces first. So we'll resolve mv square by r and this mg. देखो क्या होगा. This is mg cos theta sin theta. This is mg cos theta. So now we have the components of mv square by r as this is mv square by r cos theta, and this is mg. Sorry, this is no. This is mv square by r sine theta, and this is mg cos theta. This is mv square by r cos theta, and this is mg sine theta. All of you understood till this point or not? Please tell.
Yes, sir.
मैं ना इसको थोड़ा अभी जगह पे लगा देता हूँ. अब एक बात बताओ. If, please pay attention, if mg sine theta, or एक minute, if mv square by r cos theta, v is very small, v is small, right? It's less than mg sine theta. This object will have a tendency to slide downward. Yes or no? Say yes or no. अगर mg sin theta mv square by r cos theta से greater है, then what will happen? The object will try to slide. Yes or no?
Yes.
Yes.
Yes, na? All of you. Ramya, Shri, Nirakshana, Navina.
Yes, sir.
Yes, sir.
Okay. Sarvesh.
Yes, sir.
Now pay attention. What will happen? Since this object is moving, has a tendency to move downwards, there will be this friction which is upwards. Friction will act. Now friction, if friction is there, this friction will start acting upwards. Yes or no? And what is the limiting case of this friction? Fs max. And what is the value of it? It's mu times n. What is n here? It's mu. N is what? This is n. And opposite to n, there are two forces, mv square by r sine theta and mg cos theta. So what is n here? N is mv square by r sine theta plus mg cos theta. This is n here. I hope all of you understood what is this Fs max is. Yes or no?
Yes.
Yes, sir.
And we are finding for no sliding, right? For no sliding or no slipping. So the net force in limiting case, the net force is mg sine theta minus mv square by r cos theta minus Fs max is equal to 0. When you substitute the value of Fs max as this, okay, you get V minimum. After rearranging, of course, V minimum is root of Rg tan theta minus mu upon 1 plus mu tan theta. I hope all of you understood this. Yes or no?
Yes.
स्तुति जैन, आपको समझ आया या नहीं आया अभी?
Yes, sir. Understood.
अब इसका दूसरा पार्ट तुम लोग देखना, ठीक है? अब क्या होता है दूसरे पार्ट में? फॉर नो स्किडिंग. For no skidding. Achha, those of you who are seeing it for the first time, you are able to understand it or not? What is happening? See, these results are important. Derivations, nobody is going to ask you in this chapter. But of course, if you are in 11th standard, you should be able to understand why this thing is happening. And if you are in Maharashtra HSC board, this derivation is there in your 12th standard portion. So please do it seriously. Huh? And 4 marks derivation, every year it comes, most of the times. Every alternate year they ask this derivation. So for no skidding, what will happen is, in this case, we are increasing the value of V. We keep on increasing the value of V. And then what happens is, mg sine theta becomes lesser than mv square by r cos theta. So what will happen to friction? What will happen to friction here? Friction will act in the downward direction. Yes or no?
Yes, sir.
This is for second case. This was for first case. This was first case. This is second case. So now we have what? mv square by r cos theta minus mg sin theta minus fs max is equal to 0. So from here we get v max as root of rg tan theta plus mu 1 minus mu tan theta. चलो ठीक है, प्लीज कॉपी इट क्विकली. हो गया बेटा सबका?
No, sir.
Done?
Yes.
Yes, sir.
See, try questions from HCV. ठीक है, there are very few, मतलब very less questions in this chapter. कुछ मेरे ख्याल से कितने हैं इसमें? Tomorrow we will be doing exclusively numericals based on this chapter only. ठीक है? Do objective 1, objective 2, all of you. Complete objective 1, objective 2. And at least solve these questions. 30th. 25, 26, 22, 20, 24, 23.
Sir, I have a doubt in the 24th question.
Do it again. Today we did that. ठीक है, आज हमने किया है. ये जो रेंज निकाला है ना बेटा हम लोगों ने. हेलो,
Yes, sir.
आज जो रेंज निकाला है ना हमने, वी मिनिमम वी मैक्सिमम का,
हाँ सर.
उसी टाइप का क्वेश्चन है ये. एक बार दिमाग लगाओ अपना इसमें फिर से. ठीक है?
Okay, sir.
हाँ, हो जाएगा ये. कोशिश करो, बनेगा. लास्ट क्लास में कुछ होमवर्क दिया था क्या? आई गेव यू सम होमवर्क इन द लास्ट सेशन.
Read.
Yes or no?
Yes, sir. Read
Acha,
the
read the chapter. Okay. See, till 15 question, 15 nahi, till 14 question, 14th one, do this, all the problems, and then 20, 22, 23, 24, 25, 26, and 30. Okay, objective 1, objective 2. This is what you should do. At least complete objective 1, objective 2 before tomorrow's session. Meet me tomorrow. If you have any doubts, we can definitely discuss it and do it. Tomorrow, we will be doing numericals based on this chapter only. ठीक है, मैं एक्स्ट्रा नहीं पढ़ा रहा हूँ तुमको कल, बट कल हम लोग सर्कुलर मोशन करेंगे. ठीक है.
Yes.
बट प्लीज रिवाइज एंड कम. ऐसे बगीचा समझ के घूमने मत आना आपने. ठीक है. चलो बाय, टेक केयर, गुड नाइट.
Bye, sir.
Thank
Good
you.
night.
Thank you.